Our lecture for today is the fall of a body through a viscous medium. Viscosity. Viscosity is a measure of a fluid's resistance to flow or is a measure of the resistance of a fluid to deformation under shear stress. Viscosity describes the internal friction of a moving fluid. A fluid with large viscosity resists motion because its molecular makeup gives it a lot of internal friction. A fluid with low viscosity flows easily because its molecular makeup results in very little friction when it is in motion. It is commonly perceived as thickness or resistance to pouring. Viscosity describes a fluid's internal resistance to flow and may be thought of as a measure of fluid friction. Thus, water is thin, having a low viscosity, while vegetable oil is thick, having a high viscosity. Defined informally, the quantity that describes a fluid's resistance to flow. Defined mathematically, the ratio of the shearing stress, F divided by A, to the velocity gradient in a fluid. Units. The SI physical unit of dynamic viscosity, Greek symbol, eta, is the Pascal.second, Pa.s, which is identical to Newton second per square meter or 1 kilogram per meter second. The CGS physical unit for dynamic viscosity is the poise, P, named after Jean-Louis Marie Poiseuille. 1 Pascal.second is equal to 10 poise. What is viscosity? The question of what is viscosity is often best answered by this example. Imagine a styrofoam cup with a hole in the bottom. If we pour honey into the cup, we will find that the cup drains very slowly. That is because honey's viscosity is large compared to other liquids' viscosities. If we fill the same cup with water, for example, the cup will drain much more quickly. For a particular liquid, the higher the viscosity, the greater the density. Stokes' law. Let us consider first sedimentation of small spherical objects of density ρ in a solution of density sigma in a gravitational field G. We know that falling objects reach a maximum, terminal, velocity due to viscosity effects. As shown in this photo. We treated the entire situation as a race. Once the race was over, we asked why the marble dropped fastest in the water and slowest in the glycerol. We explained that it was due to the different viscosities of the fluid. Stokes has shown that for a spherical object of radius r, the retarding force F and terminal velocity v are related by F equals 6 pi eta rv. When the particle is moving at a constant speed, the retarding force Fd is in equilibrium with the difference between the downward gravitational force Fg and the upward buoyant force Fb, the weight of the liquid the particle displaces. If we consider Fg acts downward and Fb acts upward, and the difference is equal to Fd from Fg minus Fb equal to Fd, we obtain the expression for the terminal velocity, sedimentation velocity. V is equal to 2r squared g, ρ minus sigma, divided by 9 eta. Effect of blood hematocrit and viscosity on vascular resistance and blood flow. Note especially that one of the important factors in Poiseuille's law is the viscosity of the blood. The greater the viscosity, the less the flow in a vessel if all other factors are constant. Furthermore, the viscosity of normal blood is about 3 times as great as the viscosity of water. What makes the blood so viscous? It is mainly the large numbers of suspended red cells in the blood, each of which exerts frictional drag against adjacent cells and against the wall of the blood vessel. Hematocrit. The percentage of the blood that is cells is called the hematocrit. Thus, if a person has a hematocrit of 40% of the blood volume is cells and the remainder is plasma. The hematocrit of men averages about 42, whereas that of women averages about 38. As shown in this photo. These values vary tremendously, depending on, 1, whether or not the person has anemia. 2, the degree of bodily activity. 3, the altitude at which the person resides. Effect of hematocrit on blood viscosity: the greater the percentage of cells in the blood, that is, the greater the hematocrit, the more friction there is between successive layers of blood, and this friction determines viscosity. Therefore, the viscosity of blood increases drastically as the hematocrit increases. If we consider the viscosity of whole blood at normal hematocrit to be about 3, this means that 3 times as much pressure is required to force whole blood as to force water through the same tube. When the hematocrit rises to 60 or 70, which it often does in polycythemia, the blood viscosity can become as great as 10 times that of water and its flow through blood vessels is greatly retarded. Another factor that affects blood viscosity is the concentration and types of proteins in the plasma, but these effects are so much less important than the effect of hematocrit that they are not significant considerations in most hemodynamic studies. The viscosity of blood plasma is about 1.5 times that of water. The medical applications of viscosity. 1.by measuring the viscosity of blood we can state whether the calculated viscosity of blood is normal or not, anemia or polycythemia. 2.to compare between the viscosity of two different fluids. 3.to measure the density of any liquid materials. 4.by knowing the blood viscosity we can know the velocity of blood in the blood vessels which is indirectly proportional to the blood viscosity. 5.by knowing the blood viscosity we can know the temperature of blood in the blood vessels which is indirectly proportional to the blood viscosity.